you. So, Andrei is the vice president of Zillow Group, and now he'll give us a speech which is titled How to Build Multi-Billion Search Engines Using Open Source Technologies. So, we're waiting to listen to how we can do it. So, you're welcome.
Hello, good. Perhaps in Moscow it's good evening. It's here 8 o'clock in United States West Coast. Let me share my screen. 1 second. Google Chrome. Share. Do you see my screen? Hello.
Oh yes. We hear and see you pretty well. Yes, we see your screen.
Okay, let me move to 1 second. Share. No, 1 second. I want to go to presentation mode. Okay. Hi. So basically, I would like to give a talk and demonstrate. I will explain in more details in a few minutes how to build multi-billion search engines using open source technologies and how what benefits you get using from open source and actually what are limits of open source. So also and how to overcome them. So a little bit about myself. I was a core contributor to Google Search, started early immediately after my PhD in 2006. I was core contributor to Apple App Store and iTunes Search. Each of them multi-billion. Apple Store was, I think, 12 billion at the moment, iTunes comparable. I co-designed and co-implemented Apple Map Search in 2010, built Walmart Grocery, has been leading search teams in Zillow now, which is first leader of real estate search engine in United States. Walmart and eBay, has a PhD in computer science from the University of Manchester, UK, and my path was from core contributor to Google Search and then leading search ecosystems of market leaders of real estate, e-commerce, and digital distribution. And also basically I was doing designing, building, implementing, improving, running multi-billion search engines for last 15 years. Some of them were proprietary, some of them open source based, so I will tell what makes a difference. So my goal for this talk is I want to demonstrate that using open source significantly helps in implementation of search engines, continuous improvement, both in search infrastructure and in search quality, and also, of course, supporting operations. As you run a search engine with hundreds of millions or billions of users, certainly you need a continuous support and operations, and actually open source helps there also. And typical search engine of that scale uses hundreds of open source products and libraries. I will focus on some of them which are proven to be most useful, help most, and I will also focus what I used rather than giving full overview of everything on the market. So how I'm going to prove my previous point. So I will show a reference architecture of a typical multi-billion search engine. Of course, they're different depending on different focuses, different domains, but I will show more or less typical reference architecture. I will show a typical open source based implementation, what open source used and where. I'll show limitations of open source implementations. Perhaps it can go more to question answering session about limitations and how you overcome them. So my talk is limited to 30 minutes. I'll be brief. Topic deserves perhaps a dev tutorial. And I will try to be not just going too deeply into one particular open source system. I will give overall general overview of everything. If you have questions, let's go in QA. I will focus again also more on what I used or tried to use, rather than giving comprehensive survey of 20 open source packages. Doing this one, I will talk about 2, 3. I know how it works, and that is really focus, useful. And I will focus also what is useful for very different types of search applications, rather than what's good for image search or what's good for audio search and so on. So what's my multi-billion search engine? What's the topic? Why is the name? Is this in the topic? Multi-billion of what? So I talk about not some small search appliances. Again, I'm not also about super huge as Google, but more in middle. So multi-billion dollars in revenue or gross merchandise value, multi-billion users, multi-billion queries per day, and multi-billion of documents. How these numbers are relevant to the software discussion we are going to do. So multi-billion dollars of revenue or gross merchandise value or whatever metrics, economical metrics, implies that like once you have billions of dollars of revenue, it means you can get also billions of dollars or at least hundreds of millions of dollars of gains because of improving search engine, other search quality, or in indexing or in search infrastructure. And it also implies continuous work on search quality, search features, search infrastructure, ranking improvements to get this $1 billion gains, right? And open source is a great help. That's why we will talk about open source in context of $1 billion businesses. And complexity of the search stacks and many features implied, like, you know, like if you have multi-billion-dollar business, typically it's complex business. It also implies complexity of the technology serving this. And again, open source helps to deal with this sort of complexity of software. Multi-billion users implies a very high load, multi-billion queries per day, tough through output requirements, and of course, latency requirements related. It of course goes to distributed deployments for high load, and open source helps to solve a lot of those technical infrastructure problems. So first one, this one, both infrastructure and quality, machine learning, AI problems, where open source helps, and also software complexity. Here is more about high load problems, and open source is also great help also here. And another size typically for such systems is multi-billion of documents, right? If you have a search over some small catalog, you don't need frequently open source. You can use something simpler, but multi-billion documents, like if you go, let's say, like eBay sales system, right? Like a web search, or sometimes not multi-billion of documents, but close hundreds of millions of documents, like what we have in Zillow in our search of properties in the United States, implies distributed retrieval and ranking system. To run over these billions of documents, you must have complex search functions, because, you know, like if you have small document, like document corpora size, you can afford that your system is not very high precise because you have small number of documents on the top, user find anyway. If you have billions of documents, you have a lot of noise for every query. And again, of course, if you have multi-billion of documents, you have very frequent index updates, and it also implies a lot of requirements for technical infrastructure regarding indexing. And open source again helps with that. So are there many search engines based on open source? And it's all that, like Google, Amazon, eBay, Microsoft, being kind of big search engines, Yandex you can put here. They use own proprietary technologies. And why they don't use open source, right? First of all, like search engine is core of their business, and they have big teams to work on this and improve this. Complexity of ranking index is well beyond what open source provides. So open source is good for some tasks, but, you know, like you will not scale current open source software to Google scale, for example, and then huge monetary and user gains, your customer satisfaction gains because of optimization in different, like size of the index updates, ranking query understanding, integration with other systems. They need to handle this, and open source is not good at that level of complexity. And again, each company has a big search team to improve and develop their search engine. You know, again, if you don't have that big team, you cannot afford that complexity of running your own proprietary stack. It's easy to move with open source. Some companies like LinkedIn, eBay moved from open source to proprietary at a certain point, but it was when they were really big big business around that. Are there many search engines based on open source? And I'm talking about, again, multi-billion search engines. Yes, like Walmart is e-commerce is a good example. I think what now, I was leading this team now, I think it's around 20 billion revenue. Of course, Apple Store and iTunes, another I believe also 20 plus $billion per year now. Adobe Cloud for Elastic, based on Elastic Stack. Uber based on Salesforce. And if you go to conferences like Activate or Elastic On, it's industrial conferences for particular open source stacks such as Solar or Elastic, you'll see a lot of industrial teams presenting how they use open source for their tasks. So if we consider kind of all search on the left, like relatively simple applications, like you have a small website or small e-commerce catalog with several thousand items, typically people use software as a service, and there are plenty of companies there. On the right side, you have huge Google, Amazon scale. Then again, it's more convenient to use instead of course, software as a service will never work for that scale. Open source, super hard to scale. You build your proprietary stack. So open source is handles everything in between, and it's perhaps 90% of businesses around. And historical reasons why people use open source are very important. Like we built custom, like when I built Apple Search, co-designed and co-built in 2010, we built our own solver. Synstack was not good at the time, both in like high load and search quality. Now it's significantly improved. Instead of spending a lot of time building by my own, I would build on top of Solr. Now I would use the same. And then my another company, which I was helping with, Oslo, we sold it to Facebook. We needed a graph language for our natural language to database search, and we built our own knowledge graph based sources. Open source was not good at the time. Now I would make another decision. So what's typical search engine, high level overview? So this, like, of course, it may depend, but it's more or less the same across many big search engines. So on the left, you have data acquisition. It's everything related how to get data into the system. It's acquiring data from multiple sources, but also like deriving data inside using your data science, machine learning, what you can derive about this particular, like if you sell something, what this item about, for what users is good. So you have all data acquisition. Then on the top, you have UX, so like how people see the system when they search. Search assistant services are all services which help people to search. So it may be like type ahead after suggest, after completing your query, maybe a left-hand navigation panel helping you, like, and it's very prominent for e-commerce. When you select item, when you like you type, like, let's say Samsung TV, and it will advise you, you can filter Samsung TVs by screen size, by different different types and so on. Query understanding is once you type your query, how to understand your query, meaning, and use it in search. Indexing is using data from data acquisition and making them available for retrieval. Retrieval search engine which retrieves items based on your query provides usually first level of ranking, then high level, like more precise ranking, which requires more features than available in the index. Then you have a search engine result page logic, which a lot of ranking based or like more advanced ranking based on personalization or diversity of results and so on. And then you have a lot of like, I would say, auxiliary services like logging, monitoring, experiment management, many others. And I will show that open source actually helps to almost every square or of this architecture, and you can use open source to verify or use to build search engines based on this architecture quite fast. So what the key main components as described. So usually you say search quality is search assistant services, query understanding, ranking, SERP logic. So everything which is responsible for the final user experience. What makes results good for you, what makes order of results, what are results retrieved, how they presented. This I would call search quality. Search infrastructure is more like everything which is responsible for running system. It's retrieval, indexing, logging, monitoring, ops. Other indexing I don't include here, so more like retrieving results and everything related. And indexing is everything how to get data and make them available for search. And it typically includes, besides just getting data, a lot of cleaning data, mapping into common dictionaries to make them available for search, extraction of data from them, duplicate resolution. So assume you have a search about businesses, right, or about products, and you acquire data from thousands of different providers and like other crawl from the web, how to resolve that this particular web page talks about the same item as this particular from the feed, right? So all this duplicate resolution and indexing are called aka indexing. So query understanding. So basically, task is given a query, classify it, understand it. You have very short limits. You have a big number of queries, typically thousands, tens of thousands, hundreds of thousands per second, and it may requires large vocabularies, many components for classification, heavy CPU and GPU load. So like example of query understanding, what does it do? You're given 52 inches TV Samsung Alexa. You want to understand category TV, size 52 inch, brand Samsung, some additional information that it must have Alexa. And maybe you want to also derive from this query some semantic information that people who buy 52 inches, they agree from 48 to 60 inch. and so on, that maybe they will also agree to buy Sharp instead of Alexa or Sony, sorry, instead of Samsung, and so on. So what open source? There is a big set of libraries focus on NLP, and some of them can be used like some of them Python quite slow, but you can make also fast. Some of them like fast checks are extremely fast. You can use them. So there is a classical set like fast check. No, fast checks is, I would say, it's not deep learning, it's shallow learning, but shallow network, but it's very efficient. There is Stanford CoNLP, Apache OpenNLP. They're very traditional NLP libraries. Maybe they don't give you very high by comparing to modern SOTA, like state-of-the-art models, but they're actually pretty high precision and coverage. You can build them for using in practical purposes, very efficient, and they are frequently used to build this type of systems. There is big set of new deep learning based libraries like Hugging Face Transform is extremely popular. Basically what they do, they make all modern libraries like from Google, BERT, Roberta, Facebook, and so on. Everything what happens from academic community, they make very fast. It's available as open source contribution, and you can easily use both code and data for this to reuse, to use to building your stack. There is a Flare, a good natural language library from Zalando. Facebook PyTeX is PyTorch-based set of library NLP set from Facebook. OLM feed, and then like for example for some other, so those libraries are applicable for many tasks as classification, extraction of entities, and so on. And OpenMNT is library for machine translation. If you're like frequently you build multilingual search in many natural human languages, you want to translate from one, like someone asking German, you want to translate in English, and you want to build a translation service which is good for your particular domain. This library is quite good for that. Again, for building query understanding, latency and through-output requirements are tight. You have to process it for every query, and a lot of work is done like how to make it fast. It's hard to do it like for example, transformers are good for offline processing. They're not super fast, but like fast text has a lot of advantages, and you can build pretty high performant models using them. And then besides just libraries to run online, you have libraries how to build your tools, how to build your lab environment to build good to train NLP tasks. Docana is a notation tool to create training sets. Allen NLP from Allen AI is, I would say, like a lab environment, how to test models, how to create your training set. So like as you work as scientist, this lab environment. And Snorkel Metal is another good library, like how to create weak supervision tools, weak supervision sets, which are very popular in natural language processing. And all those create a great lab environment. Search assistants, right? So if you want to after suggest and type ahead queries, like Solar and Elastic, two kind of big names in open source to create search, they have such features which you can have as default by your search engine, but frequently like, and you get them as default as part of this open source distribution, and they're reasonably good. But they're never good if you really go to high quality and you have to build a lot on top of them. But this open source is used to be used as a basis for a library which you built on top of this. And frequently you get building on top quite big difference, plus 30% engagement for e-commerce and so on. But still open source is useful as basic block to build your solution. Then search assistants, other like if you go to Amazon and you search, you see this left-hand navigation facets. So this is very important part for this kind of small billion-dollar search, especially for e-commerce. It did not prove very useful for web search or let's say for local search, but super useful for e-commerce. Many people engage this. It really helps them to find what they want. Both Solar and Elastic has their own part in their open source distribution, but again, building on top of this, your data science-based stack and how to select and build proper panel actually gives big conversion, 15% up conversion for e-commerce. You can understand if you have $20 billion, right, say, operations plus 15%, it means quite a lot. So using this open source going on site and building on top of it can give a lot of money for the company. And it's big advantage that you have this as open source and can easily go and get insight what you can improve. Ranking, how to rank results. After you get a set of results, you want to rank them, right? You have a query with all information derived about user. You have a user with all information about user. You have a set of retrieved results, and you want to produce the most optimal optimal order of result optimized for either click-through rate or conversion rate or gross merchandise value or revenue per session or many other ways how you like how you decide the best search experience for search agents. Very tight limits, up to 50 milliseconds maybe. A very big number of queries you have to do each per every query. A lot of results, so it's kind of complicated computational procedure. And there are like what's proven, a set of learning to rank technologies, machine learning to rank. They're proven quite well for this because they handle complexity of many query user document features. In typical search system, you have certainly hundreds up to thousands of them, complexity of ranking functions, tuning for various metrics and retuning as metric change. Sometimes you require some intervention on top of that because of policies which are hard to express as functions. And there is also a lot of open source for this. So there are several approaches how to do learning to rank. There is old SVM rank and so on, and there are more new methods like based on gradient boosted decision trees. There are a lot of packages, open source packages like XGBoost, CatBoost, actually recent development from Yandex, really great package. SVM light, very old, but still useful for simpler tasks. And you can use this open source to build your search stack ranking based on these packages. And there are different ways. So typically you generate model, convert into source code of your ranking engine, compile and deploy this, but open source packages are super useful for this. So you have a Solar LTR contrib model. Also besides those, you have Google TF ranking, which is part of TensorFlow, also pretty great. And you have RankClip. I worked with this little bit 6 years ago. I know it's still alive, not sure how well it works, but they implement a set of important useful ranking methods. For ranking, you need feature storage, so you have typically multiple layers of ranking, super fast and efficient retrieval layer to go through million results, select top 1,000 of them, and then you have a ranking function on this top 1,000, and then you may have even more for personalization and so on. So you need a feature storage, right, which will deliver very fast features for 1,000 results for query at runtime to rank to apply your function. And then there are a lot of open source like Redis, Google Fist recently released, white column stores are very useful here, document stores. So any, would say, multi-column database optimized for multi-ID lookup, and there are plenty of solutions in open source which works on that. Post-ranking, after you want to rank results, they want to rearrange, remove results, like for example, frequently for e-commerce, right? You have one index of your results, but then also all results change price continuously and cannot do it in index with so frequent rate of updates or availability. And you have external sources which describe this external new features. And there are many other ways why you rank results, for example, personalization. And here you need again also feature storage, key value stores optimized for read, write, and Redis and many others from that family helps. Caching. Certainly for search, you frequently you have your a billion queries per day or whatever, hundreds millions of queries per day. And it's big load on the system to process all of them. And you need to pay a lot of hardware to be capable to this. And caching helps a lot by reducing this load. And there are caches implemented in Solr and Elastic. So there are in existing open source packages, but sometimes you want to build on top of those because you want to cache also a high set of results at the page level when you merge different results of search and so on, right? And there is a Redis memcache, all this set of very fast write and output sets when you can store small set of values, so like document per ID, which is your search extend, and open source is very useful to implement this layer. And then, of course, as you do search, you do a lot of machine learning, NLP training, you do a lot of data science, and there is big set of tools, provided by open source to create your lab environments. There is a Spark, of course, and there are getting maturity machine learning platforms such as Kubeflow and MLflow. I'm recently playing a lot with Kubeflow. There is PyTorch, TensorFlow is kind of low-level library stacks to build your machine learning stack on top of them. Again, as I mentioned before, this XGBoost, CatBoost, and this would deserve a very big conversation how to do. But so basically, open source is super useful of that. And then, of course, there is very classic cron stack, which is again maybe does not scale for well for super huge tasks, but it's super useful for many smaller tasks and data science tasks and search, like time series modeling if you want to do from my experience, spatial modeling. They have a lot of great packages or everything in open source. And then if you want to do analysis of A/B tests, contextual bandits, a lot of other experiments. So open source stacks built around R and cran is super useful for this set of tasks. Then how to retrieve like results. So given a query, you want to return an ordered list of document ID and first score, which helps you then to build more advanced score. And there is a big Lucene ecosystem, Solr and Elastic for those documents, for these tasks. It's very big open source system with many people, many companies using them. There are certain limits, but it's actually pretty good system now, pretty mature. There is Yahoo Vespa, which Yahoo released like 3-4 years ago. And there's like everything from Yahoo search, which is not used for web search, but for smaller like Yahoo Flickr news. Then there are like geographical features inside Solr. If you want to graph retrieval, you have a lot of good open source like Neo4j, Giraffe, TitanDB, and there is like another important like vector search when you there are Facebook Face and Microsoft SPTAG, big tools to build those sort of solutions. So and typically sometimes you build your search engine using several of these. So you can process some queries, part of queries a graph retrieval, part of this as text retrieval. And then like, for example, if you build a special search, how to encode special information into index, there are sub-libraries. They're not really solutions, but like Google S2 Geometry, GTS Topology Suite library are very useful at this step. And but you know, like any real search implementation, it will not be like you will use open source by default. How to optimize, how to shard it will require a lot of work on top of this. Like for example, both Solr and Elastic are good for limited cluster size, but once you're going into scale to very large collections, which require, let's say, hundreds of nodes, there are a lot of problems using them. And another limitations of open source, there are a lot of progress recently done in index compression techniques, which are really important once you go to big search. None of this available in Solr, Elasticsearch. Default query parsers are limited, so open source is great, but there are a lot of also big limitations which you have to overcome as you build this. What about indexing and data acquisition? So indexing is like typically 3 big steps. Acquire to get data from all external sources, web, feeds, databases, and so on. Maybe petabytes per data, quite normal. Hundreds and billions of days per day is quite normal for this type of system. Enrich, merge, resolve duplicates, remove noise, normalize, clean, enrich. It's another big task. And then index, map into a format understandable by your retrieval system. So for acquisition, getting data, there are a lot of great open source packages. Like if you want to crawl massive amount of web, Apache Notch, if you want like go to billions of pages, is great. Apache Atlas is more like knowing all your data sources to fast capable to discover data and think, okay, I want to acquire this data into my system. A lot of domain specific data acquisition tools, kind of if you go really low and you want to get data for some particular, there are a lot of big open source support for that. If you want to transport data from our outside system, like Apache Kafka, Pulsar, great open source tools to do this. And of course, once you get data into yours, before indexing them, you want to keep in your system, you want to merge data, how to work this. There are a lot of great open source, I would say, database solutions like Cassandra, HBase, all of them. The open source is a really great tool to help you to build this part of systems. Enrichment. So, you know, like if you typically it's kind of stream processing, so Spark, Streaming, Flink are really great at that open source solution to use for this. There are a lot of all this duplicate resolution, a lot of like, I would say, data science, different logics, which they're not really good. You just reuse maybe some machine learning built on top of scikit-learn or like NLP. If you care about NLP, you can use Spark NLP, or like other, like what I described before, NLP packages you can use here, and like a lot of predictive analytics. So there is no direct open source to use here, but like for particular task, but overall like orchestration, airflow, and then like streaming, there are great open source tools. And as you go to indexing, typically all this, like what I described, retrieval engine above, they have pretty good own indexing solutions on their own. And then you care about orchestration, right? Because acquisition, enrichment, indexing is typically pipelines of hundreds of individual components of small jobs, not small, but some of them big, but hundreds of jobs. You want to integrate external data, you want to enrich them with internal data, you want to enrich them with derived data, you want to clean, remove duplicates, merge duplicates, and so on. So there are like hundreds, thousands jobs sometimes, and typically written in also different languages, Python, Java, Scala, and so on, accessing different data stores. And there are good open source support like Flow for big stuff, Luigi for small stuff to do here. So I have like 5 minutes. So there are a lot of like low-level open source libraries, which once you build big search stack, you use here and there, and like you use them 1,000 times in different areas, like RPC, protobuf, Snappy for compression, gflags for like how give flag processing, glogs, Google benchmark for macro benchmarking. Again, like if you go with location-based search, S2 geometry or GTS library, like building unit testing for your stuff. Then if you do, like certainly once big search systems, they are massively distributed. So okay, about distributed tracing, it's important for debugging, understanding system, Jagger, Apache Skywalking. Open source helps you into this sort of building your operations for this. And then of course, ops of search operations. Like typically, like let's say 7 years ago, you was doing this on your own, bare metal, and just some direct, like, like building Apache, Solr with Zookeeper and so on. Now there are a lot of tools around Kubernetes environment. First, Kubernetes is open source, and Knative gives you a lot of good stuff, how to deploy, and then for your serverless stuff, like many small services you want to run and such like that. There is Blue Mixer operator, how to run Solr on K8 cluster, and there are other tools which are useful for running your operations, like House Monkey for testing, killing some instances over time and see how your system is resilient. So there is a huge number of tools, open source tools to run your operations. Sol Cloud, so like Solr is just itself Solr, but once you want to run your big cluster, fault tolerant, high available Solr cluster, Solr has Solr Cloud as extension. Like typically, once you have big search, it's distributed across multiple data centers across the world and or country at least. So yeah, there are tools from those open source tools to replicate to help you with this task. Of course, there are big, and there are like for your ops, there are like Jenkins for deployment, Terraform for defining and provisioning data centers. So there is very great open source tools to support it. You don't need to build on your own. And there are other big blocks once you build this your search, which is important to cover, and open source helps there. Like if you want to run A/B experiments, define experiments, decide what to do, there are like Facebook Plan Out, Intuit, Wasabi, Wix, Petri, tools to experiment management. You, of course, in your ops and also assessment of quality, you need a lot of reporting, graphical reporting based on logs, Grafana, Kibana, and then like how to stash your logs, how to transfer them, Logstash, FileBit, Fluent, and there are a lot of open source tools which are really useful for this sort of task. You don't need to build them from beginning. This kind of classical search as you go to eBay or Walmart or Zillow and search something. Right now, a big direction, very promising, how to create conversational search, such that you can come and talk to the system. You know, I'm looking for a house. What type of house? 5-bedroom. What location? Locations somewhere close to a waterfront in Seattle. Do you care about good public school district and so on? So a conversation with you to help you in search. And there is a RASA, great open source tool. They have very good dialogue state management. They have NLU system. I think NLU can build better on your own, but dialogue state is really great there. There are a lot of more like academic open source tools coming from like this dialogue state tracking competitions. They're not usually very mature. It's like some PhD student or some research group wrote them, but some of them actually pretty good to adopt. And if you want to do, like automated speech recognition, people use most, like there are big providers like Google, Amazon, Nuance. Sometimes you have to build on your own. There is a Nemo from NVIDIA, which is tool to open source tool library to build your own automated speech recognition if you need to run on your own. There are like this, like for task-oriented dialogues, RASA is great. If you want to build question answering, so you have a big set of documents, and you want, if someone comes with a question, want to find the best paragraph which answers this question. There is again a lot of like tools there for Marco, Tanda. They typically, again, sort of not very mature open source. You have to work a lot of them to adopt your environment and also like code quality. But they're available as open source, and it saves a lot of time in your developing this set of technologies. And then if you want to build natural language search over structured data, there are again open source packages, mostly sort of academic level, not very mature, requires a lot of work, but they're available and helps you to start and build your systems. So conclusions for this talk. Open source technologies are useful to build many parts of search engine stack for big search engines, from low-level code using libraries like gRPC, protobuf, to using big open source system which kind of cover a big part of your search stack, such Solr, Elastic, Kafka, TensorFlow, runtime. Each part will require a lot of work, so it will not be like you install open source, it works. It will require a lot of work to tune it for your environment, code on top of it, design ops for these operations. Uh, don't be surprised if you have to rewrite certain part open source to your implementation as you scale, and open source typically is intended for sort of average use case. And typically if you run really big search engine with like your index size goes to hundreds of billions of source, it's not what the open source intended. So frequently you have to rewrite it. But it's really useful to start and build on this, and sometimes it's actually work for a very long time for what you want to do. Search engines is a joint work of many people, hundreds typically, even more. There are many people who know like open source packages. So if you use open source rather than your proprietary technology, it's very easy to hire people with this expertise rather than say, okay, we have one search engine, we have to learn this. It's more easy to hire someone who knows Solr or Elastic. A search system requires continuous, never-ending evolution. They're always being modified, changed. And open source, like having rather than buying some commercial box packet, which you don't have access in, certainly open source helps you because you can go in and modify and improve the system. And very few companies can afford a really big system to have proprietary stack like Google and so on. So open source based search is a solution for majority like of other like multi-billion businesses, but not at Google scale. It helps you to build your search. So I finished. Thank you very much.
Okay, thank you, Andrei. We have some questions, so let's start with questions from the chat. So the question is, what about pros and cons of mixing proprietary open source solutions in a single project or in a company?
I don't see any particular cons. This is what you usually do, right? You have sometimes you have some very good proprietary software. Sometimes you use open source, right? The problem is with proprietary is always how to improve this, right? Again, because typically like open source requires, sorry, not open source, search requires continuous improvement of every component, right? And with proprietary, you fast go to these limits what you need more than your software provider provides you. And basically, if you mix proprietary with open source, for proprietary blocks, you cannot improve as much as you want. Sometimes you don't need, like some parts, like for example, many companies, they want to use Solr retrieval and they don't really care about improvement of business. So like if like that part of Solr will be proprietary, it will be fine for them, right? But like, frequently, once you go to really big scale search, you want to improve every component, and proprietary gets you these limits that you cannot improve that part as much as you want.
Okay, thank you. So the next question, according to your opinion, which tasks are not covered enough by open tools?
Which tasks are not covered enough by open tools? Like once you build, like for example, NLP for search, right? One is like this runtime environment, like how to build query and how to do like query understanding. There is big part of like how to to create data for this, like how to build proper like for example dictionary for spell correction, for language modeling, how to do proper synonym expansion. And this task is very little covered. There are a lot of good research papers, but there is no open source for that one. So like for example, a lot of those NLP synonym expansion tasks. They're almost not covered. Then what I described, once you build index, right? There are a lot of these tasks which actually in every search system, like in the duplicate detection, given a set of product description or set of business descriptions or set of web pages, how to decide which of them are duplicates. There is this task is very common in building any search system, and there is huge amount of research, as you know, in database community on that. There is no good data open source package. So I think if you say what task is not covered, mostly like I would say data science, machine learning, particular task here and then stack. Sorry, and there is very little open source to cover those tasks.
So machine learning almost not covered by open source.
Particular machine, like you have a lot of open source low-level libraries. Like let's say you can build a lot of stuff on top of PyTorch. But how do you do duplicate resolution? Let's say for businesses, or how do you do duplicate resolution for e-commerce products, right? So given a set like there are many online e-commerce shops, every of them solves this task, how to do the resolve duplicates that this description of this TV is exactly the same as talking about the same product as this TV or Canon camera, right? But there are no really good open source. There are small academic packages here and there, but not good open source focused for this domain specific machine learning and data science task, like duplicate resolution, synonym expansion, and so on. And each of them has tremendous value, like having good duplicate resolution, you improve your search experience very much, means customer satisfaction, means conversion. But every company, and there are like perhaps, like hundreds of companies doing local search, everybody doing it on its own because there is no good open source for that.
Let me ask Andrea Kali to make a question to Andrei.
Hello?
Hello? Oh, I am unmuted. Thank you. Yes, my question is, maybe it's a naive question, but does the linked data cloud play any role potentially in all this, and how does it relate to open source?
Which data cloud? I did not hear. Can you repeat, please? So I did not hear the first part of the question.
Just a moment. We'll solve it. Andrea?
Yes, so I'm here. Linked data cloud, all this RDF data maintained by communities and openly available on the web, such as DBpedia and the like.
Yeah, certainly they're useful for many tasks, right? So you must have data for your domain, for your search. Certainly for this, what I described, enriching your search with some external data, then using this in search, certainly it helps for some search tasks and for many search tasks. And you have a lot of good data in DBpedia, in another, like it covers some domain, does not cover well other domains, but certainly this open data are useful for a lot of search tasks when you enrich your index with them, and then you design your search system to understand this data and use them in search. Certainly they are useful.
Thank you.
Okay, so one more question. Recently, search engines are concerned about the issue of fairness in the rankings. So do you know any open source tools that try to handle this particular issue?
Sorry, what issue? I did not hear.
Again, issue of fairness in the rankings.
Yeah, I know fairness is extremely important in Zillow. We pay really a lot of attention to it. Like we're working in my experience, always work on like this. Perhaps a good example of those particular machine learning problems which don't have open source. I know like Google or someone recently released or Facebook that they do some tools. I did not try those tools, so I cannot tell how they're good. But up to now, up to this recent time, I was always dealing with this because there were no open source tools to support this. I think Google has TensorFlow, some package now to assess fairness of TensorFlow, like inference, which perhaps applicable to TF ranking also. But I did not try the tool, and I always solve this. And I did before, I did not see any tool to have a really good support for this task, for understand fairness of ranking.
Okay, thank you. Also, the question about maybe you can tell something about DevOps plus open source in the context of the search engines. For example, usage of Docker, how it works. Is it?
It works pretty well now. Like what I see, like majority of search operations moves to that space, right? And there are different what DevOps team use from Terraform and other based for this like data center provisioning packages like code as infrastructure, sorry, infrastructure code, and server like Kubernetes family maintainers is like movement and big help for search because again, like search is typically to run a good search ops have to run like hundreds of different services, from indexing up to query understanding up to ranking, and Docker-based environment. Kubernetes is extremely useful for that, for this type of operations.
Okay, one more question. It is interesting to hear about NLP models for generating text in the dimension of fake news and propaganda. Could you say anything about this this topic?
It's not a search task. I know that like with this, like what I described, transformers and there is GPT-2, you can create, like really good text generators, right? I would we were like actually like using for more like giving information about item you want to provide or about search results, how to generate a good textual description for this. And then you can tune for different, you can make it more like, let's say, emotional level of user. I know that you can train system in particular for misinformation and generate text based for that, again, using different types of inference. I did not work for that, but I know like with GPT-2 and other tools, actually this task kind of generating fake news becomes as a attainable, solvable language generation problem. But in search, we are focused on language generation in a little bit different context.
Okay. And additional question into it: should they be closed source in this case?
In which sense?
Okay, I think it will be better, Vladimir, if could you ask pronounce the question? One moment, we'll grant the permission.
Yeah, thank you very much, Andrei, for the talk. Actually, I cannot turn on my video, but this is exactly what you told. The question was about the GPT-2 because it's and new models. They are very powerful for faking different types of texts. Also, like fooling search engines in some cases. Probably, I don't know. And in this case, the question basically is, should they be closed source if the company understands that the trained model, the weights and the actually could be used in an improper way to do some bad things. What do you think about this issue? It's open sourcing and closed sourcing of this
Like
models. Mm-hmm. Thank you.
Yeah, I understand your question and your concern, right? And I know about this problem in particular, right? And there are two areas of research in this area, right? As you see in recent articles, one, there is a lot of research how flexible and powerful a model can be used to generate text. From another point of view, there are a lot of research you can see recently about using BERT for adversarial textual attacks and understand that this text is generated by another model, and there is also huge progress in that area, right? So like different ways, and certainly there is big progress how to make artificial text for faking news, and again there is a big progress how to do automatic recognition that this text was not made by human but by generated by another computer model. So there are good progress in protection tools, and I expect what this harm done by development of GPT-2 and making it public such that many people can use it, let's say for SEO to generate artificial pages. Actually, companies at Google, Facebook scale, can you also detect this and do against spam protection, against fake news for spam protection, fake news protection, and so on. So I feel like, so first, like harm from that these models make public, I think not that big, because protection tools are also quite easy to develop now. And of course, it's how to scale them at that level, but there is a big progress in that area. But I believe, like I don't have final opinion on that moment, but I believe that like open sourcing these tools, we certainly get some danger into the air, but from another we allow a lot of progress, because this model is also super useful for many tasks which are practical for users. And maybe how much progress you get in making thousands of search engines, not currently thousands using GPT-2, but in a longer term, maybe like advantage for society is stronger, and hopefully, like, yeah, there are always malicious users. Hopefully we will find good tools to fight them. So I don't think that, at least to close those progress, is any immediate need. I think it's good to keep it open, because there are a lot of advantages which many teams in industry get from using this model for proper goals, improving customer satisfaction and so on.
Okay, thank you very much for your answer. I agree with your opinion, and it's kind of, this the war of the sword and the shield, and it should be open source, of course, and the people can get profits and benefits of both parts.
Thank you.
Thank you again for the talk.
Thank you.
Well, let me thank Andrei for the great talk. I mean, it was really nice for him to offer his contribution. Let me remind that Andrei is a graduate of MIPT, like the rector of Innopolis University. And so he's, perhaps this talk for him was like a virtual return back home. And so I don't know, we cannot talk much virtually, but we hope to have other occasion to have Andrei to join us, and perhaps even to visit here in Innopolis. So thank you.
Yeah, thank you very much. It was amazing to be here. Yes, I graded MFT. Yeah, I hope to one day. I was not there for a very long time, 20 years. Thank you very much for invitation for this conference. It was really amazing. Great. Thank you very much.
Thank you. And now we are already saw Lori, who is there. I saw that Carlo, who is there. Tony is there. Thank you, all of you, for being here. Now I would propose to have a 4 minutes music break until we start with the panel, and then the word will be on Tony to moderate the panel on the future of software engineering digital conferences.